Lastly, let's look at the error bound for Simpsons rule. So again, Simpsons rule gives us an approximation to an integral, and we know there's some error, but we don't know the true value of the integral, so we don't know the error. So it helps to have an upper bound for the error that we might be making. It gives us some guidelines of how accurate we are if we fix the n, but it also helps us to choose an appropriate n if we want to keep our error within certain limits. In this case, we start by looking for an upper bound k for the absolute value of the fourth derivative of f on the interval from a to b. We find that the absolute value of the error we might make using Simpsons rule is going to be less than or equal to that k times the length of the interval to the power of 5 over 180 times n to the 4. So let's use this to choose an appropriate n to guarantee that the error we get when we make the Simpsons rule approximation to the integral from 1 to 4 of 1 over x dx is going to be less than 10 to the minus 6. Well, we start by finding an upper bound k for the fourth derivative of f of x on the interval from 1 to 4. Here, repeatedly differentiating, we find the fourth derivative of x is 24 over x to the 5. Now again, 24 over x to the 5 is decreasing on the interval from 1 to 4, so its highest value is going to occur at x equals 1. So for every x in the interval from 1 to 4, the fourth derivative of f at x is going to be less than or equal to 24, and of course greater than or equal to 0. So the absolute value of the fourth derivative at x is going to be less than or equal to 24. So we can use 24 as the value of k in this formula. And now we would like our error to be less than or equal to 10 to the minus 6. We know that whichever n we choose, our error will be less than or equal to 24 times 3 to the 5 over 180 times n to the 4. So if that quotient, 24 times 3 to the 5 over 180 times n to the 4, is less than or equal to 10 to the minus 6, our error is also guaranteed to be less than or equal to 10 to the minus 6. So we're going to look for an n so that 24 times 3 to the 5 over 180 times n to the 4 is less than or equal to 10 to the minus 6. The only unknown in that inequality is n itself. Multiplying across by n to the 4 and dividing across by 10 to the minus 6, or multiplying across by 10 to the 6, we get n to the 4 must be greater than or equal to 10 to the 6 times 24 times 3 to the 5 over 180. And n must be greater than or equal to the fourth root of that, which turns out to be 75. Most certainly n equals 76 will work, and if we're happy with an error equal to 10 to the minus 6, we can use n equals 75. Notice this n is considerably smaller than the one we figured out previously for the midpoint rule using the same upper bound for our error. This is also a conservative upper bound for the error. The actual error for n equals 76 is minus 8 times 10 to the minus 8. However, if we're estimating, we don't really know what the actual value of our integral is, so we're not going to know what the actual error is.